the goshawk.
Do you ever look at someone and wonder what is going on inside their head?
Hey, and welcome to another episode of Making the Right Play. I'm your host, Ishi, with my co-host,
Manit.
Today we have an extraordinary guest. We have Tomas Bencomo, a CS in Bio Computation major at Stanford, who is also my roommate. How's it going, Thomas?
It's going pretty good. How about you?
Not too bad. You know, it's going. That's all I can say for myself. But Manit, how are you doing?
Yeah, I'm doing good. I was just curious as to like how you guys met and like what your relationship is like.
Oh, yes.
Oh God,
do you want to go or should I go, Ishi?
I guess I kind of forgot, but like I remember our first conversation being at Stanford. At Stanford being at TAP. Really? After power? Is that right?
Well, that's too far back. I don't remember that much.
Okay,
that's
okay.
like
I'm just gonna contextualize it. But like, we and
Yeah.
Thomas, we were both assigned to the same freshman dorm, and we lived on the same floor. And the first quarter of freshman year, we both were in the same like writing class that Stanford makes mandatory. That you have to take for your degree requirements, and we were in the same like version of that class. And I guess like we were like, oh, we didn't know anybody in that class, but we like had seen each other briefly across the hall, right, a couple of times before that class. So we were like, hey, like I'm gonna get lunch, and then like I just would tag along with him, and I guess like that's how we like met each other, quote unquote that. But yeah, but we've been close friends ever since, and like we moved together sophomore year, we moved together junior year. And then we're not going back senior year, but we probably would have found some living arrangement like that if you were back.
Right.
And yeah, I guess that's like kind of like a brief history of me and Thomas. But Thomas, you have anything to add to that?
No, that sums it up pretty well. I mean, yeah. I think the only other thing was like I noticed I met Ishi because his roommate actually was in like a chem class with me.
True.
So like the combo of that plus I was always in his room doing chemistry homework with his roommate. So kind of how we met each other. Yeah.
Gotcha.
But yeah,
and
anyway. Oh, go ahead.
Yeah, no, I was just also like, so Ishira has told me a lot about like the work that you do and the biocomputational work that you do, but I just wanted to know, like I was just very curious about like what your history was like all the way from like getting into Stanford and like the stuff that you did and why you kind of chose that field in the first place, and like just a kind of brief history of your life, I guess.
Yeah, sure. So, how far back? Let me think about this for a second. So, I'm originally from Phoenix, Arizona, actually, and then I have moved around a lot in my life. So, I moved to like Las Vegas, Nevada, at a young age, about like 5. Then I lived for several years there, and then I moved to Chicago, Illinois, and then I moved back to Phoenix my junior year of high school.
Okay.
And so when I moved back actually to Phoenix my junior year, there was a internship I was told to apply for. So at the time, I was like really interested in computer science. I had done like AP computer science. I know probably a lot of other CS people have also done that. And I was really into programming, but I wasn't really, I don't know, the app development thing, which was like really hot at that time. This is like when the iPhone had like come out a few years before. Everyone had an app. Wasn't super interesting to me. And I was like, what else can you do with computer science? And my cousin who works, he's a biologist, a cancer biologist, worked at like a local research institute in Phoenix. And he had told me about this like internship they had for high school students and college students, where you could like apply and then they would put you it was a summer program. They would put you with a mentor and then you'd work on a project with them for the summer. And so I applied. I somehow miraculously got in because I didn't have any prior experience besides a little bit of coding. Mind you, I'm like a junior at this point, so although it like may sound like I had a coding experience, in retrospect my coding was terrible. So I like worked in this project where the like group had developed like an algorithm to like look for new cancer genes in like large data sets, and the problem was the program was really slow, wouldn't run very quickly, and so I I like transferred the program to like a new faster framework that uses like supercomputers and GPU computing. So I wrote all that code. I like rewrote the code, all the code for the program. Did that for the summer. And then that kind of like really got me interested in like the field. I really liked the idea of like using programming for something other than app design or profit building, I guess, in a sense. I liked it for like the whole social good impact. I really like the whole science part of like, oh, we're discovering new things. And the research institute is like a translational institute. So instead of just doing really basic science research, they're really all about like transforming patient care. So I
Okay.
really like the whole idea of like the work that you're doing eventually going to like a larger goal of helping people with cancer, for example, or other diseases. And so that kind of got me down the path of like, oh, maybe I should do something with computer science and medicine, or computer science and biology for college and a career. And at the same time, I was also kind of interested in medicine because I have Crohn's disease, which is like a gastrointestinal autoimmune disorder. And so I've had
Yep.
like some problems with that throughout my life. I'm in remission now, which is nice. But over like the years, I've had to like switch drugs and treatments and stuff. And so that kind of got me thinking, it'd be really cool if I could like help other people with the same condition, either as a doctor, as a researcher, because I've been like blessed to have like doctors that helped me along the way that were really good. And so I kind of like learned that you could actually combine these two things into the field of biocomputation, where you take computer science, you take biology and medicine, and you together work for look for new research routes and new treatments for diseases. And I kind of was like on that path, and that kind of led me to apply to Stanford for computer science because they have like a really good medicine and biology fields as well as computer science. So I applied. I think what really got me in was that I had that research experience at that summer
Right.
research place. My mentor was great. He wrote me a rec letter. I had gotten like an abstract out of it for like a conference,
Okay.
so that was good too. That also helped. But that's kind of how I got into the field. And I've been doing computational biology or bioinformatics, whatever you want to call it, ever since then. And I will be applying to med school this coming summer. So yeah,
Got, got you. That's an inspiring journey. And I'm like, I've always been impressed every time like Ishida has even like mentioned you. But something very interesting that you mentioned is just that you got into like you're interested in getting in like med school. But I feel like this is not the most conventional path that people take to get into med school. Right? I feel like at least on my end, like the general story is that people either get into pre med or they do like a biology, just like a pure biology major, or something along those lines. So could you just like outline the differences between like the traditional approach to medicine, like so the traditional like pre med approach versus just how you went about it by combining both biology and CS, and identifying the medical kind of applications to both those fields.
Yeah, I'm gonna
yeah,
I'm gonna add to that as well because like
Yeah.
when I left school, I thought I was like quantitatively decently strong, but I hadn't even heard of like biocomputation, and I had like a big interest in bio at that point, right? But like yeah, I hadn't even like remotely heard of biocomputation. I didn't know the work it entailed until like I met Thomas, and he's like, oh yeah, I'm biocomp, and like it is interesting, but yeah, it's like, definitely something that I'm curious about as well.
Yeah.
yeah. So I think the general. So I'll just like talk about the general path first. So like as you said, like the average person takes, and like what my route was. So the general path that most pre med students take is they get into medicine. They're interested in medicine for whatever reason in high school, either because someone was like, oh, you should go into medicine, or they want to help people. They like biology. Some people are in it more for like the nice lifestyle, the nice salary, and all that. There's a lot of different
Yeah.
routes.
Yeah.
And so from there, most of them they do a biology major, either
Yeah.
biology or at Stanford. There's two different complementary majors. There's a biology, which is just like straight biology. So you both get like an education in human stuff,
Yeah.
human biology, but also like plants and other animals, organisms as well. And there's the other major called human biology, which is solely based on human biology. It also covers a lot of like other aspects that aren't necessarily like the basic science biology you would think of like DNA, more of like social science stuff as well. So like healthcare policy, like sociology, that kind of stuff. So most people will go one of those two routes where they will take all the biology courses you need to get into med school. There's 6 core courses most med schools require. Um, 6 might be the wrong number. There are a few core courses. So you need to take a year of biology with lab, 2 years of chemistry, a year of physics, and then usually there's like a year, like 2 quarters of math requirement as well. So they'll take all those, and then because they're usually a bio major or a human biology major, they'll like take advanced biology courses like immunology or cancer biology, all those sorts of things. They'll take the MCAT, which is the medical school entrance exam, in like their sophomore or junior year, and then they apply at the end of their at the beginning of their this would be the end of their sophomore year, junior year. So when they graduate, they'll go straight to med school. My route was a little bit different. So there's a few different ways you could do it. Stanford is really nice in that they have several programs that are biocomputation focused. So if I so what that means is so the CS program at Stanford has several. It's a track-based program, so there's different tracks. There's like the AI track, there's the systems track, the theory track, and the biocomputation track. The biocomputation track is really nice because it's designed specifically for pre-meds. I know you guys had said that you hadn't heard about biocomputation as a major really like before a lot, like until recently. But at Stanford, it's kind of funny. There's actually like a decent number of people who are pre-med but also do computer science as a major. When I say decent, not like hundreds, but like probably like 10 or 20 people, maybe more, that want to do both. Which is I think is like unique because I think a lot of schools, at least I think it's don't have that. It's probably because Stanford has like a great CS program, also a good bio program, and like Stanford attracts those kind of like people that are really like overachievers where they want to do both sort of thing.
Yeah.
But with that in mind, this program is nice because it takes a lot of the like core. You get like the core CS education. So I took like algorithms. I took like programming, data structures. I took like programming methodology, all those courses. But then for a lot of the other like depth requirements you have to take are fulfilled with biology or like the pre-med course requirements. So like my 2 years of chemistry, most of that counted towards like major requirements for my CS major. Although most people would say like chemistry doesn't have anything to do with CS, or like biology also counted. My whole year of biology counted for major requirements as well. And so I basically took I probably should have taken more. I took the minimum amount of med school classes required. I took like biology, the chemistry, the physics, all that. And then I tried to really focus on improving my like methodology skills and my statistics and my computer science skills for the field of biocomputation. So I took a lot of depth requirements in biocomputation classes. So I took biostatistics. I took a class on like different algorithms for computational biology. Taking another one this quarter on translational bioinformatics. So how do you take like biological discoveries and put them into patients? And then how does the tech behind that? And so I really went about it that way. And then I complemented that with I did like research I've done it since like freshman winter quarter. I've done like research in a biology lab, doing data science stuff for them. So I think the difference between the two is whereas most people get into bio and then they just stick with bio classes the whole way. I've dabbled everywhere, which is like both good and bad. So on the good side is I feel like I had like a little bit of understanding a lot of different places. Everything from I know a little bit of physics, I know
Yeah.
a decent amount of bio, I know I'm pretty good at programming and stats and all that stuff. And then whereas the problem with that though is a bio major has taken a lot more biology classes than me, obviously. So they have a much better understanding of biological pathways or like lab experiments they can do, which I'm kind of like lesser, not as knowledgeable about in. But that's kind of like the difference. There are pros and cons to both. I really like what I did because I think medicine is getting more and more digital almost, and there's going to be like everyone talks about like AI. It's the future of medicine. I'm not sure it's the future, but I do think the need to like interpret data will become more prevalent for doctors in the future. And so I think I'm kind of like definitely suited me well to like take some of those classes. And I definitely like programming more than like just learning biology pathways. So it worked out for me well.
I think that was a beautiful kind of summation of like what biocomp is really about. And it is interesting because like I also like personally I think that modern medicine, a lot of science fields are now favoring kind of applicants who are more jacks of all trades rather than the master of one, right? Because everything's becoming interdisciplinary and intersectional, and like I guess this is like a good segue to some of the conversations that me and Thomas have had regarding like doctors and them keeping up to date with new research and misinterpreting stuff. And it seems like with everything becoming more of a big data and medical data driven world, there's like this opportunity for doctors to misinterpret stuff and just like mishandle data and like you know have like false understandings of what the data says and end up like harming people in general. And personally, I don't know, Thomas, if you want to talk about it, but like I feel like you've always emphasized that a good doctor needs also to be a decent scientist, right? And those two definitely shouldn't be like two different things. And do you want to talk about that a little bit? I think
Yeah,
yeah.
sure. So I think it's like I don't know if it's a common misconception, but I think a lot of people go like, "Oh, you're studying medicine. You must be really good at science, right?" And I think there's like a difference in science. Someone who's like, obviously I haven't done doctoring yet because I'm a pre-med, but I've done like a lot of science now.
Yeah.
And like from what I can tell, the difference is science is really not so much about knowing facts and like just knowing a bunch of information, which although that's like a requirement, that's not the key. It's really about what kind of questions you ask, how you go about solving those questions or proving or disproving things. And I think the issue is that medical school is not structured for that at all. Medical school is literally, from what I've heard / been told by doctors and like been prepping for myself, it's you like learn to regurgitate a bunch of facts that you can then apply in a clinical setting, which is obviously like what doctors need to know. But that means when it comes to doing research to do like new treatments or new like caretaking rules or whatever, they may not be the best equipped to answer those questions. But having them, they've already been in school for 4 years or more, because plus residency is longer. You kind of like get to like the point where like, well, I probably know what I'm doing, or I may have had some experience, but not a lot with the like research. And so the question becomes, are you fully equipped to like understand what you're doing research wise? And so I think it is, and really that's what's, because science is research, right? It's like asking a question, solving that question with data. And so I think that's like what I kind of like liked about doing my track, at least, is because I think I've learned a lot about asking questions and using data to answer these different questions, which I hope will help me as a doctor think more critically. That's also why I want to do like an MD PhD is what I'm going for, not just an MD, to get a lot of good research foundations, so I can ask better questions in the future.
So
Yeah.
the MD PhD is like an interesting thing because I wasn't aware of it until I met you, and you told me that, oh yeah, I'm trying to do an MD PhD because blah blah blah. There's like all these different benefits to it, but you know there's also a cost to it. But I don't think anybody I know has heard of it. You know, outside of inside my circle in like Sri Lanka, it's not like a common option. Most people think like, oh, you do pre med, you do med, and then you're a doctor, and then you know residency whatnot. Yeah, I feel like anybody who hasn't heard of MD PhD, you want to sum it up? Like briefly.
Oh yeah. So the official answer is you take instead of 4 years of medical school for an MD, you spend an extra 3 to 4 years in medical school / graduate school, also getting a PhD. So you do your first 2 years of medical school where you do like all that information regurgitation I just talked about. You learn a bunch of science, medical facts. You then spend the next 3 to 4 years doing a PhD in a field of your choice, usually something science related. And then you would go back to the clinic for the last 2 years of medical school, where you do rotations and you try out different specialties to see what you are interested in. After that, you would then, most people go on to residency because they want to have the ability to practice. They practice, they becoming doctors in residency for 3 to 5 years. And then depending on what you want to do, if you want to do research afterwards, which most people do because they spent 4 years getting a PhD as well, they will go do a postdoc, usually in a lab. Sometimes they split the postdoc by also doing like practicing work as a doctor. And then most MD PhDs will go run a research lab or do some kind of research stuff afterwards. Yeah.
So I guess it's not like an option that a lot of like practicing doctors consider, right? Or people who are like.
Yeah, so there's like pros and cons. So like the reason a lot of people don't consider it is because it does add 3 to 4 years of your life, and some would argue that your like 20s / 30s are like the prime years of your life. I personally am not subscribing to that, but a lot of people do think that way. And so you are spending, so medical school alone with the MD PhD option is 7 to 8 years. You normally remember just 4. So you're already putting like say 8 years into schooling, more schooling. And then you still have to do residency, which depending on your job, your specialty of choice could be anywhere from like 3 years if you're doing like primary care, or to 7 if you're a neurosurgeon. So right there, you're looking at 14 if you're a neurosurgeon, 14 years of post undergrad education.
Oh, it's post
And so,
undergraduate, right? Right after.
yeah, so it'd
Like,
be like after undergrad. Yeah, so you're
okay,
talking
okay,
about
gotcha.
like that's like what, like
Yeah.
a long, you're like, yeah, it's like you're both older and you put a lot of time in. And so the cost of that is that depending on finances, obviously you're taking longer to get to become a practicing doctor. And I don't know if not everyone may not know this, but so residents aren't paid that well. So basically you're not really making money until you become a practicing or like an attending doctor. And so you're kind of putting off your earnings potential to get this PhD and do the extra research requirements, which some people like, I mean, it makes sense. Like it's financially difficult. So the way that the like way they try to balance that is most / all MD PhD programs are fully funded. So in the
Okay.
U.S., medical school is you have to pay for it yourself, and most medical schools are expensive. I think the average cost is like 250 for 4 years, 250,000 for 4 years, which most people take out loans for because that's like a lot of money and they can't. No one really can pay that up front. And so the problem is go to med school for 4 years. You're not making any money really because you're going to school most of the time. You've taken out a loan. The loan's accumulating interest, right? You then go to residency for 4, so let's say 4 on average years, and you aren't making a ton of money then either. You're making enough to like live, but not residents aren't paid very well. So you've spent like say like 8 years total after you've done med school and residency. Now you're a practicing doctor. You now have like loans worth like $350,000, $400,000, $500,000, which you need to pay off. Which is expensive, and people that kind of like drives people to go into private practice and drives people to go into high paying specialties like cardiology or oncology instead of one. And that's why there's like a shortage of doctors in primary care right now. So to counter that, MD PhD programs will pay for your tuition. So they give you they cover all the tuition costs of both medical school and graduate school for the whole 7-8 years. So you don't come out with any debt. But on the downside is you've spent probably, let's say, like 4 to 5 years doing research, and so which you could have been making money as like a practicing doctor. So it's like a financial trade-off. So yeah, those are the pros and cons of.
But yeah, on the other hand, do you want to take us through what your life looks like as a pre-med at Stanford? I know you have some interesting stories from shadowing and whatnot. And but do you want to talk about like what life is like or was like at Stanford?
Yeah, I can talk about what I did in terms of like pre-med stuff. So I think what is my daily life? I mean, my daily life is pretty much like any other student. I do classes like everyone else. Most of my classes are, well, up until like recently, they were like intro bio chem physics classes, which is kind of boring. But I mean, there's that, like your standard, like lots of people in the lecture hall. Just like go to class, take notes, and then hopefully don't have to go to office hours because there's like a ton of people there because it's a huge class. So on the other end though, like the bio comp classes are pretty interesting. I mean, those classes consist of, if you're thinking about like what major to go to, a lot of coding, obviously. And then usually it will be like, most of them are taken, it's like you learn about some algorithm or some like data processing step, and then they make you implement it on your own. And then you are given like a toy data set or some like real world data set, and they ask you to apply what you just like programmed to like onto that data set and then draw conclusions from it. So if you like both programming, but also thinking about the results of the program and how that applies to some other system, is kind of interesting. It's kind of like transferring knowledge across systems is really like the cool part to me, instead of just like programming and being done with it. I've also, let's see what else I've done. So I've also done a bunch of shadowing, as you kind of mentioned. So I have my mentor is a dermatologist in the dermatology department at Stanford, and I've shadowed her several times at the clinic she goes to a couple times a month. And I mean, I don't think the shadowing hasn't been like, I mean, it's like normal. Shadowing is like could be like a very interesting experience. I never shadowed before. I shadowed with her. I've shadowed with her several times. I mean, I don't think that there's anything that was like super crazy. It definitely is interesting though, because like, I mean, seeing some of like the wounds or stuff was kind of weird to like for the first time. I never had seen some of those before. The other cool, just to switch over back to shadow real quick. The other thing I've been able to see, which is kind of interesting, is I got to shadow some neurosurgeries when I worked at Mayo Clinic doing some brain cancer research for 2 summers. I don't know, the whole idea of like being in like a neurosurgery room. I don't know, you see all those shows like Grey's Anatomy or whatever.
Yeah.
Surgical suites. And so you think you know what it is. It's just weird standing in a room and like 5 feet away from you, like there's like the person's like skull is just open. It's a very like, you're like, wow, it's like kind of like humbling, like, oh wow, this is like really real at the moment. Different from shadowing like a dermatologist where we look at people's skin all day, and it's kind of like less high stakes, but it's definitely a very interesting experience to be.
I have one final question that we ask every guest, and it's a weird
Okay.
one, but bear with me. It's also from Los Hermanos. We asked this at our spotlight, but it's an interesting question. If you could lick the foot of anybody in the world, fictional or non-fictional, dead or alive, who would and gain their power, who would it be? And power is defined as however you want it to be.
Their power. Oh, okay. Oh, well, okay. Power makes me think superhero, so it's gonna be a superhero, I guess. Which superhero would it be?
Or I swear to God, if you say Batman or Superman, I'm just gonna.
I was thinking about Batman, but let me think about
Batman's
this
a good
more.
choice, I guess.
Yeah,
I don't know,
Batman's
Spider-Man. Honestly, I would go Spider-Man. He's intelligent, but he also has like superpowers. I think I'd go Spider-Man. He just seems cool. He's cooler than Batman. Batman's too broody. I don't want the power of brooding. So I'll take Spider-Man. I would lick Spider-Man's foot, I guess, which is kind of weird. I guess that he's the powers that I would want. Minus the whole orphan Uncle Ben situation. I don't know.
Yeah.
That's why you
Yeah.
can't inherit you can't lick Batman's foot or else bad
Yeah.
karma.
Yeah.
Oh,
Okay.
he's had a rough time. But I think that concludes our podcast. I think that was, some awesome stuff by Thomas, and he's, as you can see, he's a really interesting person, and that's why we wanted him on the podcast. But thanks so much for coming on, and
Thanks for having me.
Yeah, it's been fun. To all the viewers who made it this far, which is really few of you, I'm sure, but thanks for listening, and we'll see you on the next episode of Making the Right Play. And cut. Thanks for listening to another episode of Making the Right Play. You can find our podcast on iTunes, Spotify, Google Podcasts, and Anchor. If you enjoyed this episode, please consider subscribing to our YouTube channel, Content. This will keep you posted on new episodes, bonus content, and blooper reels. We hope you make the right play.